Good morning, good afternoon, and good evening to everyone. My name is Achal Chaudhary, and I am the server administrator of the Fe'stem organization. This is the second week of our 3-week course. Here are the important announcements of our course. This is a 3-week course where you will be learning the introduction of AI. We have 3 modules: AI and the real world, AI algorithm and machine learning, implications of AI. After each module, we will have an assignment test whose deadline is the next week Sunday. This link will only available during the meeting or in the Discord group, so it's compulsory to join Discord. We respect each and everyone present over here, so don't try to bully anyone. Kindly abide the norms of our program. Slides will be available on demand. Module 2: AI algorithm and machine learning. This module is divided into 2 parts: real world AI and the machine learning. This real world AI is covered by me, and the machine learning part will be covered by Megha. The real world AI is divided into 3 parts: odd and probability, the Bayes rule, and the NAIVE Bayes classification. Odds and probabilities. We know that in the real world, things are not so clear cut. There is no perfection. Instead of perfect information, there is a host of unknown possibilities. Let's consider an example of a self-driving car. Suppose a self-driving car have to move from a point A to a point B in an efficient manner, and this car follows all the rules. Now, what happens if the traffic going worse as expected due to some accident ahead or due to some weather condition or something? Then we know that a self-driving car consists of many sensors and cameras. Suppose one sensor instructs the car to take left turn and the other sensor instructs the car to take right turn. Then what will happen next? We should make a pause for a while. This problem needs to be resolved without stopping the car. Here are the concept of odds and probabilities comes into picture. The probability is one of the reasons why modern AI methods actually work in real world problem, the ability to deal with uncertainty. Now, the probability has turned to be the best approach for dealing with the uncertainty, and almost all the AI applications are based on the probabilities. Why probability matters? We are most familiar with the applications or of probability in many games, like what are the chances of getting 3 kind in a poker? What are the chances of winning a lottery? Apart from that, what is the probability of comparing the risk in our daily life? It also helps in comparing the risk that we face in our daily life. For example, what are the probability of crashing a car if a car exceeds the speed limit? What is the interest rate that we get after 5 years? AI also help in successfully detecting the fractured bones in X-rays. Now, here are some of the questions in which you have to conclude the probability given by the forecast, that the probability is right, wrong, or cannot be concluded. Before solving these questions, I would like to tell you that probability can be quantified. It means that it can be expressed in numbers. That is, we can decide that the probability is right or wrong. But also keep in mind that it is usually not possible to draw conclusion about whether a particular conclusion was right or wrong based on the probability. There are 2 questions. First, the weather forecast says it's going to rain with 90% probability tomorrow, but the day turns out to be all sun and no rain. And the second question is, the weather forecast says it's going to rain with 0% probability tomorrow, but the day turns out to be rainy. I'm giving you 5 minutes to solve these questions. The answer of the first question is cannot be concluded because here the weather forecast says it's going to rain with 90% probability tomorrow. It means that for tomorrow there is a 10% probability that there is no rain. So we cannot consider the probability as wrong. So it cannot be concluded. And the answer of the second question is wrong. The weather forecast says that it's going to rain with 0% probability tomorrow, but the day turns to be rainy. It means that the weather forecast says that there is no chances of rain, but there is a rain. The rain did. So the probability is wrong. Odds. Probably the most easiest way to represent the uncertainty is through odds. By odd, we mean an expression that is like 3 is to 1. We can expect for each case the third case of an one outcome. For example, the winning of a bet. There is one case of a winning of a bet and there is another case of losing of a bet. These odds are also called as natural frequency because they involve the whole number. Why we use natural frequency instead of percentage and odds? Suppose an odd expression like 3 is to 4. This 3 is to 4 expression can also be written in terms of percentage, which is 75%. But it has been found that people get more confused and make more mistakes when dealing with the percentages and fractions than with natural frequencies. So we use natural frequencies instead of percentages. The Bayes rule. This rule provides us a way to update our views on the arrival of a new relevant piece of evidence. Suppose if a person has a cancer, then we can consider initially it as the population that has a cancer. However, given an evidence that the person is a smoker, we can update our probability since the probability of a person having a cancer, we know that the person is a smoker. This rule allows us to utilize our prior knowledge to improve our probability estimation. The formula for the Bayes rule is probability of A by B is equals to probability of B by A into probability of A divided by probability of B. NAIVE-based classification. One of the most useful application of the Bayes rule is the NAIVE-based classifier. The NAIVE-based classifier is divided into two parts. First, NAIVE and second, Bayes. Both the words has its own meaning. NAIVE. It is called NAIVE because it assumes to be every occurrence of one feature is independent of the occurrence of the another feature. Consider, for example, suppose we are recognizing a fruit with the help of its color, shape, and taste. Consider a fruit that is red in color, spherical in shape, and sweet in taste. So, with the help of these properties, we recognized an apple. This apple is red in color, spherical in shape, and sweet in taste. Here, each feature is contributed individually to identify an apple. No feature is dependent on another feature. And the term base is written because it depends on the Bayes rule. The real world applications of the NAIVE-based classifier is the spam email. The spam part of our email, the algorithm of that spam part is written with the help of NAIVE-based classifier. It is the most simple and most effective algorithm that is useful in making fast model machine that can make quick predictions. It is also called probabilistic classifiers, which means it predicts on the basis of probability. All right, that's end from my side. Now, if you have any questions, you can ask me.